Previously, we know if we have a vector A, let's say, which is x1, y1, and a vector B is x2, y2, then what do we get? We get the dot product A dot B will be the length of A times magnitude of B. They are the same thing, length, magnitude, and then times cosine theta. Okay, let's say here is A, vector A, and then here is B, and then here will be theta. Okay, so we know we have introduced two special vectors. One is I, which is 1, 0, like the one right here, horizontal vector. Another is J, that will be 0, 1, so it's the vertical vector. Okay. Now, then we know how about I dot J? Well, how many degrees between IJ? 90 degrees. Then we know it's going to be I magnitude times J magnitude cosine 90 degrees. So 90 degrees is 0 cosine. Then we finally have a 0. So you can see I dot J is 0. Since the dot product commute, we then have a J dot I is 0 as well. Okay, so then you know, how about I dot I? I dot I, then it will be length of I times the length of I cosine 0, because, you know, the same vector, and then the degree, of course, is 0 degree. Cosine 0 is 1, don't forget. And length of I is 1 times length of I is 1. So finally what you get is 1. So I times I, let's say it's I squared, is 1. This vector squared. So is the case for J. Vector J squared is 1. Okay, those are good examples for the unit vector ij. Now, we know vector, any vector A, which can be expressed as x1 I plus 1 ij, like here. A is x1, y1, and then with this vector A, vector B is going to be like x2 I plus y2 j. So we put arrow above vector symbol. And then what we like to see is how about A dot B? A dot B then will be A dot xi, I, this vector, plus y2 j, this one. Okay. So what do we have? What we have is this vector A can be distributed to x2i and then to y2j. And then recall what is our A. A is the one right here. This is our A. Let me mark it. This is our vector A. Okay. So what we have will be, then this vector is going to be distributed to the A. So that will be our x1i, this component, times x2i, and then consider this component plus y1j and then times x2i. Okay, that's first one. Then the second one will be A again. You see. A again. But this time is y2 j vector. Then we look A is x1 I and then y2 j and then y1 j then y2 I y1 j, this vector, then y2 j, so this one. Okay, what do we get? Here is x1 I, x2 I times I times I here is 1. So then we have x1, x2. The second one here, y1 j dot x2 I. You see, this is the second one. This one. So we have a I vector dot, we have a j vector dot I vector right here. Okay. So j vector dot I vector is 0. So then we have this one is 0. So let me put it right here. It's not coming up. Plus 0. Now right here is ji again. So you will get 0 because I dot j is 0. J dot I dot j both are 0. So you have a 0. And how about this one? This one you have a j here. Okay. J dot j is j squared, and you have 1 here. Okay, look at this one. So you have this one is 1, and then you have a y1 times y2. Okay, so this basically tells us that if vector a dot b, then what you get is x1 times x2. So then plus y1, y2. You do not need to have this. Okay. So what was x1, x2? x1 is the component of A, first component. B is the first component of B is x2 here. So basically, A dot B is this vector dot this vector dot this vector plus the second component times the second component. Okay, so that would be the very good answer. Very good answer. So this basically is a dot product of two vectors is the sum of products of their corresponding coordinates. Okay, so right here, if here was our A, x1, y1, and here is B, x2, y2, then what you get will be what? You will use x1 times this x2 plus y1 times this y2. You do not have to find out the angle in between vector A and B. That's very fortunate. Okay, so basically, that's a very useful formula. Okay, so we do not need to know the angle. But actually, the dot product is convenient to find out the angles in between two vectors. Okay, you see, here we have a length A times length B will be the dot product of vectors A and B. That's previously defined. Now we have those two are the same. Okay, they are equal. So what can you see? You then see is that we can basically find out cosine alpha. Very interesting here. look. We know for this A, what is the length? Length A is just the square root of x1 squared plus y1 squared. So is the case for B. So that's x2 squared plus y2 squared. Okay. So basically, if we are given two vectors, A and B, then we can find out this value. We can find out this value is here. Is the value here. We can also find out this value is the value here. And we then find out this value. So we then can find out cosine theta. It's very interesting. Okay, so what is cosine theta? We have a x1, x1, x2 plus y1, y2 equals, let me copy the A, B here, dot, no space, let me move it a little bit. Yeah, cosine theta. So what can we do? Both sides divided by length A, length B. Okay, those are vectors. So I like to mark it. And this side, also divided by length A, length B. So we then cancel this one. Then what we get will be cosine theta equals x1, x2 and then plus get the right pen, red. So plus y1, y2, then divided by the length of A times B. So length of A, length of A is radical x1 plus y1 squared, and then times, move this one a little bit more, that will be x2 squared plus y2 squared. Okay, so this is a very important formula. That's a new thing. So find what? Theta. So that means if we are given two vectors, we can basically find theta. So it's very exciting. Okay, so here is the one you will want to see. Oops. Where is, right here. Not here. Keep going. Right here. Oh, no. Yeah, this one. That's the formula we need. Okay? I'll see you next time.